But practically, is it possible? No, it is impossible. This is false. In our practical situation, it is false because there is frictional force. This frictional force of the surface opposes the motion of the ball. So the ball cannot move continuously. Practically, the ball cannot move continuously because there is frictional force applied by the surface on the ball. Okay. So, the main conclusion of Galileo from his experiment is the ball on the smooth or frictionless surface roll in a straight line. That is, when the ball moves in a frictionless surface, that is, the surface has no friction, it is very smooth. When the ball moves on such a surface, it rolls in a straight line and at an unchanged speed, that is at a constant speed forever. It rolls in a straight line and at a constant speed forever. Okay, so in order to stop this ball, what can we do? Here in this surface there is no friction and it is very smooth. So we have to stop this ball. There is no frictional force. Then in order to stop this ball, what can we do? Yes, we have to apply the unbalanced force on the ball. Okay, we have to apply the unbalanced force. Otherwise, the ball will continuously move. That means, in the absence of unbalanced force, the object will continue in its motion. That is, in the absence of unbalanced force, the object continues in its motion. The object remains in its motion when there is no unbalanced force, and the object moves in a constant speed. If there is no unbalanced force, in the absence of unbalanced force, the object continues in its uniform motion. Okay. When we apply the unbalanced force, the object will stop. These are all about the Galileo's experiment. Based on this experiment, Newton made 3 laws. Okay, based on Galileo's experiment, Newton discovered 3 laws, that is Newton's laws of motion. Okay, Newton's laws of motion. So we move on to the Newton's first law of motion. What is Newton's first law of motion? That is, we already discussed here. Do you know? According to Newton's first law of motion, an object at rest or in uniform motion will continue to be at rest or in uniform motion unless an unbalanced or external force acts upon it. Okay, what is Newton's first law of motion? Simply we can say that an object at rest or in uniform motion continues its state of rest or in uniform motion until we apply an unbalanced force acts on it. Simply we can state that every object continues to be in its state of rest or of uniform motion unless an unbalanced external force acts upon it. From our everyday life experience, we know that when we pushes a ball, the ball slows down after some time. This is because the frictional force comes into play and this frictional force stops the ball. So, hope you understand. Let's check another activity. Suppose a ball is moving. In order to stop the ball, we have to apply an unbalanced force. Okay. In order to stop the ball, we have to apply an unbalanced force. So, the ball will continue in its uniform motion till we apply an unbalanced force on it. Hope you understand. Similarly, suppose a ball is at rest. In order to move the ball, we have to apply some unbalanced force. Otherwise, the ball will continue at its state of rest till we apply the unbalanced force. Okay, that is what is saying the Newton's first law of motion. That is, an object at rest will continue to be at rest unless an unbalanced external force acts upon it. And an object in uniform motion will continue to be in its uniform motion unless an unbalanced external force acts upon it. This property of an object is called inertia. The law is called Newton's first law, and the property of this object is called, and this property of an object is called inertia. Okay, this property of an object to keep that object itself at rest or in uniform motion unless an unbalanced force acting upon it is called inertia. The property of an object to keep that object itself at rest or in uniform motion is called inertia. Hence, Newton's first law of motion is also called law of inertia. Then, how can we define inertia? Do you know? Imagine you are running very fastly and somebody asked you to stop immediately within a second. Will you be able to do it? What if you suddenly turn towards the right? Will you be able to turn immediately? The answer will be no. We cannot do this suddenly, but we can do this slowly. Why? Why we cannot do this suddenly? Why couldn't we stop suddenly? Why couldn't we turn right suddenly while running fastly? While running fastly, we couldn't turn right suddenly. We couldn't stop suddenly. Why? What is the reason behind this? That is the inertia. That is because of inertia. Every object has this inertia. Every object continues to do what it's doing. Every object likes to do what it's doing. If it is at rest, it will remain at rest. And if it is in motion, it will remain in motion. This property of an object is called inertia. The tendency of an object to remain in its state of rest or in uniform motion is called inertia. The tendency of an object to continue its state of rest or of uniform motion is called inertia. This is the definition of inertia. But what can change this inertia of an object? What can change the inertia of an object? That is, we already said in Newton's first law of motion. What is Newton's first law of motion? Every object continues to be in its state of rest or of uniform motion unless an unbalanced force acting upon it. Okay, so what can change the inertia of an object? Yes, the unbalanced force. The unbalanced force can change this. Okay, an unbalanced force can change the inertia of an object. Then, what is inertia? The tendency of an object to continue in its state of rest or of uniform motion is called inertia. Hope you understand the concept of inertia and the definition of inertia. Then we move on to the types of inertia. There are 3 types of inertia. What are they? That is, the first one is inertia of rest, and the second one is inertia of motion, and the third one is inertia of direction. Inertia of rest, inertia of motion, and inertia of direction. These are the types of inertia. Let's look at inertia of rest. The tendency of a body to continue to be in its state of rest is called inertia of rest. What is rest? The tendency of a body to continue its state of rest is called inertia of rest. That is, if an object is at rest, it tends to remain at rest. Let's take an example from our everyday life. We have such an experience while traveling in a bus. When a passenger standing in a stationary bus and the bus suddenly started to move, what will happen? You can see the passenger will move backward. Why does this happen? Why does the passenger move backward? This is due to the inertia of rest. The inertia of rest experienced by the passenger. The body is at rest when the bus is at rest. When the bus starts suddenly, the lower part of passenger contact with the vehicle that started moving. The lower part of the passenger contact with the vehicle and that started moving. That time the upper part of the body continues to be at rest because of inertia of rest. So we move backward. Okay. So we move backward due to the inertia of rest. The passenger moves backward when the bus starts to move. This is because of inertia of rest. Let's move to the next example. Place a coin on a smooth piece of cardboard covering and this cardboard covering an empty glass. Strike the cardboard with the finger. What do you see? Yes, on hitting the cardboard piece flies away. Okay, and the coin falls into the glass. What do you see? On hitting the cardboard piece flies away and the coin falls into the tumbler. Why? Because here the coin is at rest. When the cardboard is at rest, the coin is at rest. On hitting, the cardboard moves and the coin continues to be at rest. Okay, so the coin continues to be at rest and the coin falls into the glass. Hence, it is because of the inertia of rest of this coin. There are many daily life examples for inertia of rest. That is, fruits fall down from a tree on shaking its branch. It is due to inertia of rest. That is, here the fruits continues in its state of rest while shaking the branch. These are all about inertia of rest. Okay. So what is inertia? The tendency of a body continues in its state of rest is called inertia of rest. Then we move on to the second type of inertia. That is, what is inertia of motion? The tendency of a body continues to be in its state of motion. The tendency of a body continues in its state of motion is called inertia of motion. Let's look at the examples for inertia of motion. Here, by applying the brake, the bus will stop suddenly. Then the passengers tend to move forward or backward. Yes, the passengers tend to move forward when it applies brake. This is due to inertia of motion experienced by the upper part of the body. That is, when the bus is moving, the whole body of a passenger is in a state of motion. By applying the brake suddenly, the lower part of the body that is in contact with the bus comes to rest. However, the upper part of the body moves. That is, the upper part of the body remains in the state of motion. That is due to the inertia of motion. Okay, so the passenger moves forward when the bus stops suddenly. There is another example for inertia of motion. Look at the fan in your room. When you switch off the fan continues to rotate for some time. Isn't it? This is also due to inertia of motion. Let's look at another example. A person sitting in a train moving with a constant speed. The person throws a ball upwards. Due to inertia of motion, the ball returns to thrower's hand because the ball also covers the same distance as the train does. Then, what is inertia of motion? The tendency of a body continues to be in its state of motion is called inertia of motion. Then we move on to inertia of direction. What is inertia of direction? The inability of a body to change the direction of motion by itself. It is the inability of a body to change the direction of motion. When a body in motion cannot change its direction, this inability is called inertia of direction. Let's look at an example. We have such an experience while traveling in the bus. What happens when a fast moving bus negotiates the right hand curve on the road? The passenger will tilt to the left. Yes, this is due to the inertia of direction. Then what is inertia of direction? The inability of a body to change the direction of motion by itself is called inertia of direction. These are all about inertia, inertia of rest, inertia of motion, and inertia of direction are the types of inertia. Then let's move to the relation between inertia and mass. How can we relate inertia and mass? Let's do an activity. Take two boxes, one empty box and other filled with sand. Which box is easier to move, the empty box or box filled with sand? Yes, it is the empty box easier to move. Why? Because empty box has less mass and the box filled with sand has higher or greater mass. Which one has more inertia here? Yes, the box filled with sand has greater inertia because it is very difficult to move the box filled with sand. That means the box filled with sand has a tendency to continue its state of rest. So we can conclude that greater the mass, greater the inertia. Or we can say that as mass of an object increases, the inertia of the object also increases. As mass of an object decreases, the inertia of the object decreases. So, greater the mass, greater is the inertia of the object and greater will be its resistance to change its state. That's all about Newton's first law of motion and inertia. What is Newton's first law of motion? Every object continues in its state of rest or of uniform motion unless an unbalanced external force acts on it. What is inertia? Inertia is the tendency to continue in its state of rest or of uniform motion. There are three types of inertia: inertia of rest, inertia of motion and inertia of direction. Then we will discuss the Newton's second law of motion in the next class. We will continue in the next class. Thank you.